Hi everybody. To finish up our talk about transformations of functions, we need to look at stretching and shrinking. Once we've looked at this last type of transformation, we'll put everything together by looking at multiple transformations.
So before we really start talking about stretching and shrinking, I want to give you a couple pictures of it because I do think this is probably the hardest of the transformations. So look at this f of x. It's kind of this u-shaped one, and g of x is the transformation. Do you see how it looks pushed down? Like it looks like it kind of got smaller. And how I kind of look at that, is it bigger, is it smaller? Kind of look at points. This point is now way down here. Let's pick another point. This point, and then I look down, it's way down here. So it's not as much. Think about if this was your money and you used to have this much, but now you have this much, it's your money shrank. It got to be less. So I want you to see it kind of got pushed down and squashed. Here's another one, same kind of thing. This is this shrinking. So f of x used to be high, but now it's at g of x, which is much lower. So I see this, it went down. The difference in going down is, see how they have the same beginning point? When we were doing other transformations like vertical, the beginning point moved. So this is not the transformation of move the whole thing up. We're multiplying by a number that shrinks it. So how do we tell when something stretches or shrinks? And that comes from the coefficient. If a is greater than 1, that means it's a stretch. It's getting bigger. If a is between 0 and 1, that means it is a shrink. Sometimes we call that condensing. A is positive. What I think about here is if there's a negative, that's a reflection. So that's something completely different. So here's a good example. I have f of x is 3x squared. Well, I know what it usually looks like. 0, 0, 1, 1, negative 1, 1. Let's draw that little graph. This 3 is stretch. And this is really by a factor of 3. So what I think about is instead of this being 1, 1, now it's way up here at 1, 3. Instead of negative 1, 1, it's now way up here at 3. So if I connect the dots, it should look like it's inside of it. It should look like it got stretched. Kind of think like a rubber band. I take the shape and I stretch it, it gets thinner. Here's one that's a shrink. I have 1/4 of the absolute value of x, so this is shrink or condense by 1/4. So absolute value, usually 0, 0, 1, 1, negative 1, 1, and you connect the dots. Now I'm changing it to a fourth. So instead of 1, it's only a fourth. And instead of 1, it's only a fourth. So here, I can see it's shrunk. It's lower. This one has 3 transformations. The negative is reflect over the x-axis. The 2 is stretch by a factor of 2. And then the 5 is up 5. So let's do that in step. Let's think about this 0, 0. And it used to be 1 to the right, 1 to the left, but now I have this negative 2. So instead of going this up here at 1, 1, I want to go negative 2 on the right and negative 2 on the left. So I did 2 things at once. I flipped it and I stretched it. So now here's the first part. That takes care of this. Now the up 5 says move it up to 5. This point was negative 2. 1, 2, 3, 4, 5 is at 3, and then at 3. So here is my x squared. If you wanted to, you could do that quicker. You could just say, like, I know instead of 0, 0, it's going to be up at 5, 2 to the right, 2 to the left. I do think that 2 tells me how far the next point goes. Here also, I have 3 transformations. I think this is the hardest one that we have seen today. Here's why it's hard. When you take this negative x minus 3, it's deceiving. Set it equal to 0. That is my best strategy here. That way I have negative x is positive 3, and then x is negative 3. So now this is going to go left 3. So what just happened? Usually when we say minus, minus goes to the right, and this time minus is going to the left. How come? Well, because negative x minus 3 is the same thing as negative 1 times x plus 3. So there's kind of a hidden plus 3 in here, and I think that's super tricky. So I think the best strategy is when you see this, like a negative x under the radical with another transformation, set the whole thing equal to 0. It will really help you out. So I know I'm supposed to go over to negative 3 because I went left 3, and then plus 2 says go up 2. So this is my starting point. And then this here, this negative says go to the left. So 1 over, 1 up, curve it around. Let's go a little bit backwards. So that was, I gave you a function, you give me a graph. Now I'm going to give you a graph and I want to know what function it is. When you look at this function, hopefully you can tell it's an x squared, and you can see that it moved up 3. So that says I have f of x is x squared plus 3. So you're just identifying the transformations and writing them as a function. The next one, this is absolute value, but it looks like it moved twice. So if I go over, let's talk about what this point is. So I went over 1 and then down 1, 2, 3, 4, negative 4. So I had two transformations. So I have f of x is equal to the absolute value. To go to the right, I did x minus 1, and then to move down, I did minus 4. So I think what makes me go to the right? Negative. What makes me go down? Also negative. This one, when I look at it, looks a little different, but overall, I hope you see this is some version of x cubed. Generally, x cubed looks like it's going up. Because this one looks like it's going down, I think it must be a negative in front of the x cubed. But I also see it pushed to the left, and now it's at negative 2. So this means I have negative x plus 2 cubed. Sometimes we don't even know what graph we have. I want to do f of x plus 4. So what I'm going to do is point by point, I'm going to move it up. So this one that's down here at negative 4, I go up 1, 2, 3, 4, I'm at 0. This at negative 1, 1, 2, 3, 4, puts me at 3. Let's connect those dots. This next one that looks like negative 3, 1, 2, 3, 4, now I'm at 1, connect those dots. And the last one at negative 1 goes up 1, 2, 3, 4, puts me at 3. There's a little bit of a curve there. Same graph, but now I'm going to do minus 3. Remember, minus 3 is right 3, so this time push to the right. So down here, I go 1, 2, 3. There's my first point. Second point, 1, 2, 3. I like to connect the dots as I go. The next point, 1, 2, 3. Connect that dot. And the last one, 1, 2, 3. Give it a little curve. This goes back to that same graph, and we're going to flip it. So whatever is negative goes positive, positive goes negative. So negative 4 becomes positive 4. Negative 1 becomes positive 1. Connect the dots. Negative 3 becomes positive 3. Connect those dots. And then the last one, negative 1 becomes positive 1. A little bit of a curve. Glad that we have this one where we're going to do a shrink. So how do we do a shrink when we have something like this? Well, we take the y-coordinate and we multiply it by half. So it looks like negative 4. Half of negative 4 is negative 2. This is negative 1, which becomes negative 1/2. Connect the dots. Negative 3 becomes negative 1.5. Connect the dots. And the last one says negative 1, so I make it negative 1/2, and I give it a little curve.